अंतरिक्ष मिशनों में इलेक्ट्रॉनिक्स उपकरणों का निर्माण और संयोजन शीघ्र ही पाठकों को उपलब्ध होगी और ऑलरेडी अभी हो चुका है। और आई थिंक जो माननीय गृह मंत्री श्री अमित शाह ने उनका विमोचन किया था, तो यहाँ पे हमारे पास पूरा ऑडिट होगा। और उन्होंने इसरो के अंतरिक्ष कार्यक्रम में सक्रिय रूप से अपना सहयोग प्रदान किया है और उसके द्वारा हजारों बच्चों का मार्गदर्शन किया है। विदेश की विभिन्न तकनीकी व्यावसायिक संस्थाएं जैसे इंस्टीट्यूट ऑफ इंजीनियर्स, इंस्टीट्यूट ऑफ इलेक्ट्रॉनिक्स एंड टेलीकम्युनिकेशन इंजीनियर्स, ब्रॉडकास्ट इंजीनियर्स सोसाइटी, एस्ट्रोनॉमिकल सोसाइटी ऑफ इंडिया, इंडियन सोसाइटी फॉर सिस्टम इंजीनियरिंग के आजीवन एवं फेलो सदस्य हैं। उनके द्वारा आईईटी के करीबन 10,000 से अधिक बच्चों को अभियांत्रिक इंजीनियरिंग की पढ़ाई एवं आजीविका के क्षेत्र में कुशल मार्गदर्शन प्राप्त हुआ है। तो सर हमारे आईटी के सेक्रेटरी भी रह चुके हैं और उनका उन्होंने एडीसी भी ऑर्गेनाइज किया हुआ है। आईटी में उनका महत्वपूर्ण योगदान रहा है और मैं उनका स्वागत करता हूँ सर। मेमोरियल लेक्चर दीजिए।
लाइट को ठीक है। Namaskar. Let me outset first thank you to the executive committee, office bearers, chairperson, IET headquarter, award committee, our mentors, Joshi Saab, Mishra ji, our friends, Madam Bhalotia sir, Rashish bhai, and all. I feel lucky that I am on this platform, that I am giving the talk of having 35 years of experience in this field. Basically, Dr. Vikram Sarabhai is our father of space program, and what he thought, what the successors implemented, that the space program should be for the human mankind, and it should be such that within the low cost we can do the benefit from the sky to our Indian citizen. So my topic today, what I am trying to communicate is this, that basically what is enabling India's space future, space electronics hardware realization, industry's growth. That is the title, and which I want to cover in another 45 minutes. F3 condition. Okay. Okay. So basically, the space electronics is representing the pinnacle of high reliability engineering. It is not excusing us. We want a zero defect product, and in that particularly, starting from the design aspects, component selection, processes, man, machine, material, method, all these things are very important, because the space electronics has to bear the extreme conditions, environment conditions, and the how this started basically. The way back in 1991, when India started its own basically the space hardware manufacturing in our own labs, starting from INCC 2 onward series, the things went well, and we had our own clean rooms, and later on it was thought that yes, we have to start with the industry participation. So my point of telling you is that very interestingly that how the company, how a vendor got incorporated with our own program, with our own space engagements, and how it was converted. Nowadays, it is very interesting to note that how the industries are making not only our Indian satellites, but they are making the satellites for the foreign also. So that is what I want to highlight. Not only that, how high reliable precision control they are doing, and whatever the things that we are unable to do in our own setup, the industry partners are now available and they can do it. I think it is better that if I can do it from here. उल्टा क्यों चल रहा है? Okay, no problem. ठीक है? So let me, no problem. I will handle. I will do it. I can manage. Okay.
Up and down.
So basically, SAC and most of the people are SAC, PRL, and our own colleagues are there. So they know all these things that we have a lot of things in our SAC clean rooms and all that. So what I thought that there will be people and students will be there. That's what I kept this particular thing. That SAC is having almost 90 to 95 acres of land, and we have a lot of clean rooms and we have the manpower, and there are a lot of activities. गड़बड़ है इसमें, ऊपर अप करो तो नीचे जा रहा है. Okay, so basically what is the industrial role in the satellite? Satellite is basically what? Satellite is in electronics in terms we see that it is an amplifier. It is a basically for, if we say like remote sensing, we need lot of things, like if we start from Aryabhatta, Bhaskar and all that. So we need a structure, thermal system, solar panels. So many things are there in electronics. Major concern what I am here to explain about it, HMC design, ground support and system. So major point is that how these things started, how the beginning took place, how the hand holding was done, how the mentoring was done. So the people used to ask us, स्पेस इलेक्ट्रॉनिक्स में हम क्या कर सकते हैं, हम लोग तो कमर्शियल इलेक्ट्रॉनिक्स वाले हैं, बट एज ए पॉलिसी, एज ए दिस थिंग, वी हैव स्टार्टेड बिगिनिंग. हाउ द हैंड होल्डिंग टेक्स प्लेस? वी इनवाइटेड द कंपनीज in our campus with the proper government of India procedure, and step by step procedures we have taught them. In the electronics flow chart and sequence, there are lots of things are there. Let's say design, then fabrication. In fabrication, if we see, then the component tinning is there, then mounting, placement, harnessing, so many things, so many steps are there. So not going into much of the technical aspects of it. Let's say the stage 1 is there. So we have taught the industry support partners or industry people, ISRO support partners and all that. We have brought their people, we have taught in our supervision, hand holding was done and they were paid. It was not a free of cost. It was as a government of India part of procedure. So step by we have done it. Parallelly, you know, in space electronics, the person has to be certified. There should be the certification. There should be the lab should be certification. There the processes and materials all should be certified. Then only one can do and start the space electronic fabrication and all that. So now, in fact, if we see that, we have to convince them, भाई इसमें ज्यादा पैसा नहीं लगने वाला है, इसमें ज्यादा इंफ्रास्ट्रक्चर नहीं लगेगा. Slowly if you start that, so because it is a prototyping work, it is not a bulk work. So it was very interesting to note that going to the industry, telling them कि सब आप ये काम करिए तो करिए. How the vendor selection was done? It was again a very trivial and very this thing. We surveyed, we thought that let's start with the nearby companies and all that, so that going, coming, communication, because in those days no WhatsApp was there, no video call was there. It was only through the, it started, let's say, email and all that. So it was very interesting phenomena, interesting those days. So people used to come in our lab. We started our taking that advantage of our facilities, giving them, hand holding them, certifying them, and then parallelly we started with our request for procedures and government of India procedures in their lab certification. We guided them. Our QA team used to visit regularly to them, and their clean rooms used to get certified. In turn, they used to ask, सर इसके बाद में हमको क्या मिलेगा? इफ आई एम इन्वेस्टिंग 10 lakhs, 15 lakhs, 20 lakhs, 50 lakhs, then there where comes the person's diplomacy, person's intelligence, and the mentorship is to be done with the people. We have to tell them कि देखो भाई ये एक प्रकार का आप देश की सेवा कर रहे हैं, ये आपको एक सर्टिफिकेशन जो मिलेगा स्पेस इलेक्ट्रॉनिक्स का, मैन्युफैक्चरिंग का, उसके दम पे आप डिफेंस के सारे प्रोजेक्ट्स ले सकते हैं. So somehow some companies got convinced and they started doing that. So because why I mean all these things are there stringent criteria because they are non repairable. We have to be very reliable because our system has to work in the harsh environment. So that is why the things are there. So now we started with that also कि भाई ठीक है आप शुरुआत में पहले ग्राउंड का काम करिए, ग्राउंड इलेक्ट्रॉनिक्स का काम कीजिए. Now again the audience may like to ask the question कि क्या होता है ग्राउंड इलेक्ट्रॉनिक्स में और स्पेस इलेक्ट्रॉनिक्स में? बेसिकली द वेरी सिंपल थिंग इज दैट कि वी वांट a ground hardware as good as a space hardware, but there are differences in terms of components, in terms of inspection procedures, in terms of the certification of the people who are involved in the things. So that is very important. Very important part is there. So what we decided, what we did in that at that time frame, we have started convincing our senior management small orders, small subsystems manufacturing for the ground use, and that ground systems and ground things were inspected and the feedback were noted. You know, in our space electronics and also we maintain the logbook, that is in the commercial terms what we in our terms we call it the history cards. So we used to tell, we have to tell to the person and the company's manager and managing director, look, this is what we want. We used to show our photographs and all that, and then they got a confidence that yes, this is the thing. And the industry growth, see, it is very surprising that ERTL West and EQDC, those kind of thing in the 2000, they used to come to SAC and get acquainted with these things, and that knowledge and that procedures they wanted to adopt for their inbuilt systems and for training purposes, so that the industry's quality gets improved one. That was basically the idea about that thing. So we need skilled manpower, we need basically the clean room, certified lab, we need the man, machine, materials, processes and all that. And then what basically in terms they got understanding. Many parallel industries got started coming up, and then we have to use, and we convincing them, you see, this is what we can do it. So here, this is the photograph I just wanted to tell. Anyway, people are aware of this thing. This is from in those days it was named as Solectron Centum. Now it is a 4,000 crore plus company. It is named as it is listed company, Centum Electronics Limited nowadays. So he is the managing director, Appa Rao. And this is the award, certificate award ceremony what we visited there in Bangalore in their campus, and that was the approach. That was I wanted to point out, that the approach and attitude towards the company. It's not like that being in sitting in the government on the other side of the table, theek hai baat post bhej do kar do. That was the thing, and that was discussed with the management, and that is the first time that for the SMDs, surface mount devices, and the through-hole components, that mixed assembly qualification took place. And when we started talking to them and all these things, so it was a mere 10 lakh rupees order in those days, and we went that कि साहब हम तो ये process qualification है, हमको इतने कार्ड बनाना होगा, ये करना, all these things we explained them. तो initially they said कि साहब ये तो मेरे लिए peanut जैसा है, we don't want to put in our manpower and our these things and all that. They totally refused all these things. But somehow it's various levels we had a meeting, we discussed, and somehow we got convinced, and this process of qualification and certification went very well for 16 months. And finally that our QA QC clearance के बाद में certificate award ceremony के लिए that we decided that our team will go to their office and will award the certificate in their premises to that managing director.
Which year was it?
This was in 2007. So this is the thing, and the managing director, Dr. Appa Rao, is there. This is all the concept in those days. putting the certificate in golden frame and going and packing and all that. He was our ex associate director, Dr. Ram Ratan, a tough person in those days, it was known. And after seeing that certificate and the wording and all that, it is the first time made bilingual certificate. And after seeing that, he wept for 3 minutes. That is the beauty of that thing. And then, everybody was sitting on that in the conference room and that thing. And then what after we had some work there and we visited there, after 8 to 9 months we went there, that copy was again multiple copies was put in the different halls. That certificate. He was so feeling proud that some government agency has come. So the message what I want to communicate is that this kind of thing, if we want to develop the particular things. So if you name either Maharshi Electronics, if you name it Komalin Electronics, there was a company, Velar International, that is not surviving today. But if you take Kens Technology, if you take name Agista, whatever the big players are there nowadays in the country, they have gone through all these kind of phases and all that. So this way the things were developed, and this is things kept in this thing. So the advancements of nowadays in fabrication technology. So we have not stopped in that only. Let's do only the card wiring and all that. So it has already enhanced for the harnessing. It has already enhanced for the packaging. It has already enhanced for the so many things basically later on slowly to this thing. So not only that PCB, bare PCB fabrication, layout design, PCB wiring, assembly, testing, packaging. See, this whatever you are seeing in this particular card is basically the local porting and all these things. So there are 95 processes are there. If you it's a gasket fitting, if you call it as a toroidal coil winding, if you call it as a mechanical work in the particular assembly and packaging and all that. So all these things they were taught. They were very well. They were given the training. They were given the hand holding was done. And it's all in the government standing framework. It's not that any violation of the things and all that. See, there are so many things out there. कोई component damage हो गया तो क्या करेंगे? कोई component miss हो गया तो क्या करेंगे? Because see, space electronic components are very costly. So all these rules and regulations, keeping in the very minute details, were also kept in the mind. It's not just like that कि ठीक है अब हो गया तो क्या करेंगे? It's not like it's a पक्का हिसाब. क्योंकि any space electronic component, it's all serialized. It's all that even if it is damaged, we have to give it back to the office. ऐसा damage हुआ. Technically, there's so many committees and all that. So all these things was very tough handling. It's not so simple, easy job. कि ठीक है यार उसको penalty लगा दो 1000 रुपए की काम चल जाएगा. It's not a one day. It's not a one kind of association that way. So industry participation in art, it's just some glimpses. I just given this thing. We started giving in terms of joint. If you call it as in a satellite, there may be around 95,000 to 2 lakh of the joint, depending on the satellite configuration and all that. So different companies started participating in that. Some of them are listed here like that. So not only that, this thing our own setup, but Chandigarh was also participating. That has now gone and shifted to Mehti. They were already working for the ground electronics. So they were also updated because of the huge workload what we subsequently in 2015, 16, 17 we had. So we had already MOU done with the Chandigarh headers those days, and I was a focal person. I used to handle all these things sitting here only. So wiring and assembly, not only that, it's about ground, BGA soldering and all that, like that way. So point is that, see, not only the raw material for the space electronics, but the processes, drawings, all these things, the fabrication file has to be delivered to the vendor in a proper fashion, and then proper things to be done. Now, in a space electronics era, in our restricted kind of organization, what we have to see? We have to see that the things should go with the proper CISF and all that things. So that was the first started with the local. Now the time has come, time had come also earlier in the 2016 onwards, 15 onwards, 14 onwards, that we had a heavy workload and used to send the cards through proper packaging to the outside Ahmedabad. That is again another interesting phase. Space electronics, the card, PCB and components, we are sending it. So, see, if you send a card, that may be costing you 100 lakhs. You can't take a 100 lakh bank guarantee from a company which is in the starting phase. So again, from the government of rules, regulation, structures, the framework was done again between sitting with the management and the purchase and this thing, auditor, our IFA, and find out the way that how it has to take place in the transit insurance, in the freight insurance, then the company का premises में कभी उसका theft हो जाए तो क्या होगा उस केस में, सपोज हमारे 4 कार चले गए, चोरी हो जाएगा तो क्या करेंगे, what will be the subsequent action. So all these things were taken care with the point by point, all this legal aspect, so that companies manpower, if he is coming in the office, then it should not have any problem. That also we have to think on that line. So all these things were taken care and properly, methodologically it was framed out, rules and regulations were prepared, because the beauty of the ISRO organization is that many of the things, like say if you talk about quality control and all that, we have not copied. We have evolved our own procedures and systems in our own it's like a iron dome kind of things, so that it's like a zero defect kind of thing. We have evolved all these procedures and systems in the procedures and all that. So we have to see that we have to do the periodic audit of the industry, our QA, and take care of it. QC goes there and all that. So that is kind of the handholding that ISRO organization did. So now, very interestingly, I want to tell that all these companies, if you talk about say Anand Technologies, ATL, and all these things, they are capable of much more capability what they have achieved nowadays. They can make independently their own, full satellite integration, full complete total testing. They can do it. It's only a small part portion I am telling, from which I have to touch, for which I was considered, I was recommended for our office. I am thankful to my office for this purpose. It's just a precautions what we have to tell. We have to communicate to our vendors, our industry partners, that we have to do it, that we should not use plastics and all these things. So many times it may happen that the quality, we have done so many data analysis and all that. So many industries we are doing very well. Some of the industries where repeatedly they had some problem of that thing. Then we identified कि भाई इस manpower से बार-बार गलतियां हो रही है, इस particular devices में आप लोगों को ज्यादा गड़बड़ी हो रही है, तो we have tell them, we have showed them that lessons learned. So whatever the lessons learned, what we had, we have taken the photograph and we have showed them sitting all together with hundreds of hours with the industry engineers and communicating them, telling them with all polite, with keeping all patience and all that, because the designer and the project wants the timely delivery of the zero defect. They can't, because that is another Pandora box of the record I just want to tell. Design is also not manufactured many of the times. Once design is not manufactured, it's not a case for the production. But we have to do it. It's a normal thing. कि ठीक है यार, अभी तुम आटा ओसन के बना लो आधी रोटी, फिर तुमको नमकीन बनाना है, मीठा बनाना है, मैं आपको बाद में बताता हूँ. That kind of thing always happens. Things happen. But anyway, we have already gone on those kind of phases and all that. And nowadays the capability is very well established and all that. Some of the case studies I just wanted to tell that CQFP, ceramic quad flat pack devices are there, which are coming in the, we have to form it for making the solder and all that. So we had that tool and all that. So while doing some lead forming, we observed that there are lot of deformations of the lead, and the tool mark is there because there is a rail in that basically. So what to do and all that, it was from Mantex USA, it was a tool. So we have written many times to them and discussed and all that. Finally, we ourselves in our team got a solution that we have made some insert, and then finally it worked. The chief engineer came to our office. He appreciated and told that we should all together should file a patent for this. So that was a very interesting story. That's what I wanted to tell here. Okay, this was the lead पे चिन्ह पड़ जाते थे, उसके कारण जो था कि that is not acceptable, because that was showing in the, if we have a tool marking on the leads on that, so that what basically it will show that the strength of the lead in future will be decay, and that sometime in the due to vibration it may break out also. So because of that reason, that was not acceptable, and then finally after doing certain experimentation and putting that's what. Anyway, it's a reflow soldering and all that we used to do it, all these things. This is another case study that if we have a confidence in the industry partner, they can do miracles. Three things are required. One, continuous touch, hand holding, and proper technical study and guidance. So that worked. It was a recent, in a couple of years back, it was required for that Gaganyaan project. The challenge was that a 20 layers polymer board and 16 mil pitch. Thousandth of an inch is a mil. 40 mil is 1 mm. So if we have that kind of dimensions, and 200 pin connectors were there, and there were 8 connectors with the QFN, quite flat pack with no leads. That has to be soldered in the polymer PCB, 20 layer PCB, and it costed around 9 to 15 lakh something. Some was arranging was that. So without any spoiling the time and all that, doing experimentation. So we thought that yes, we will be able to do it with our own internal setup and all that, but somehow it couldn't materialize. So then finally the management had an idea and discussed, let's explore the possibility with the industry partners. It was very interesting that our own nearby one factory, I should name, and MCBS. So that again is a new baby in the space electronics. We developed that industry. And then we were knowing that they had a capability and they had a very interesting machine with them. That they had a very good printer with them. So we thought that, and we discussed with their engineers, personally gone, sitting back. So few of the, Saturdays with them, 1 or 2 Saturdays and all that. And because time was very limited, so in only one Saturday we went, and we thought that let's run on Sunday. We do it here because normal days their commercial things were going on. So we decided, we studied their total manual, how it can be done. It was a 12 zone machine. Okay, so we did that. These are the certain photographs with the X-ray also. It is, showing that thing. And this is the, challenge was there, and audio visual it worked, and it got successfully. The project got the results also. So that way is there. Basically, the technical challenge. We have to discuss, we have to see, we have to correct it, we have to respect, because the day in day out the commercial, their engineer is working. So we have thought, we understood that what things we should change considering the PCB and polymer aspect and number of layers also. Okay, this is another one kind of challenge we had in our Aditya L1 mission. This kind of configuration was, PCB was there, where 0201 type, 0201. 02 divided by 4 means 0.5 millimeter multiplied by 0.25 millimeter. Okay, so that was in 2019, end of the 2019. So certain few PCBs were to be made, and that has to be made. Do it. So manually it can't be done because it is such a complicated and things and all that. So again, we had a discuss with this thing, and Anand technology was selected by us, and then finally they did it, stencil making, machine thing. Starting from manual to going to semi-automatic, and then it was a task of semi-automatic. So in the semi-automatic it got worked, and then finally it went very well, and we know that Aditya L1 is fine. So not only that, in PCB electronics things and all that, in MIC also, microwave electronics also, it's also very tough kind of scenario is there. In that also the things went in the same parallel mode, and very few companies came into that kind of micro integrated electronic circuit because of the certain reasons. Because again here was a low volume, and the requirement were very stringent, And anyway, the money as per the government norms and pulses rules, L1 selection and all that things are there. So it was a very dicey state. So still there are 4 or 5 companies are there who are in the country who are supporting to all these things are there. And Agista is one of that company. Comolis is also one of the company. Centum has already qualified for this kind of MIC. So for both of the things, if you consider the satellite scenario for RF and DC, these companies are capable of doing any kind of satellite. If you call it as a communication satellite or remote sensing satellite, anything they can do it in a very beautiful way. So, like say bonding and then assembly, all these things not only for our human space mission, they are also doing for our like a communication payloads, interplanetary missions and all that. So they are doing it. In Bangalore, near to Devanalli, they have established a full integration room near to airport, 10 kilometers. The ATL and Centum both are they are having all these things, and that also is qualified, certified by this thing and all that. Bangalore and SAT QAQC. See, this is what the learning lessons and all that we have done it. Like say, suppose कोई subsystem है, उसमें कोई ions है, attachment के बाद में कुछ रह गया है, तो कोई flux है, तो उसमें I mean, what is the thing, what result is there, and what improvement should we do so that it should not happen. Like say कहीं deep tool mark आ गया, तो उसको पूरा analysis किया कि भाई deep tool mark क्यों आया, whether it is a operator mistake, whether it is a tool issue or it is a what went wrong. So all these things we have to document it, we have to find out a solution, we have to communicate to the operator, we have to take the action, we have to communicate the same thing to our in-house person as well as to industry person. So that kind of hand-holding and communication and close loop, the feedback has to go back so that the next time it should not happen. So like here these feed throughs are there where sometimes because of handling it इसका मुड़ जाना होता है या आपके कुछ एक्सरे के अंदर आप देखते हैं तो लगता है कि शायद कुछ क्लीनिंग प्रॉपर नहीं हुई है या प्रॉपर अटैचमेंट नहीं है. It's all the I mean for micro integrated circuits I have taken. Another so many learning lessons we had for PCB assembly and all also there. So finally what we are seeing is that we are having nowadays the space electronic assemblies, which is now in turn the development is taking place. The weight is going down, the larger outputs we are getting, and in that also the qualification and the testing has to be very rigorous. So what we need that this total thing should be in pakka mode, the design should be perfect, the things should be in line proper, so that I mean the communication, the fabrication file, the things should be in proper order. There, I mean the operator who is working, whether it is an assembly engineer or a QA engineer, he should have a totality of the things. Or I mean it's very clear in the space arena that a small mistake or small things is basically a total failure. Anyway, everybody knows that if your satellite is successful, launch fails, again the mission fails. If your launch vehicle is successful, the satellite is having something wrong during the this thing that again is a fail. Or even after the successful launch, something goes wrong beyond. I mean, it should work for a designated period, say 5 years, 10 years, 15 years. If it is not working, then it is also a partial success kind of thing. So that the कोई भी picture को hit होना है, तो उसके सारी चीजें, सारे components, सारी चीजें perfect होनी चाहिए. I mean that kind of stringent character, that kind of thing should be there for this kind of things. So what we need to for our industry partners, we have to teach them for zero defect. They have to be incorporated. They have to be given the feeling. Nowadays, anyway, the things are open, policies are open. I am coming next to those kind of slides also are there. So how I mean now they are thinking, yes, now this is a growing arena. बट दे आर उनका दुख दर्द इसमें है कि उनके पास में इतना काम नहीं होता है कि उनका सर्वाइवल या उनके अर्निंग बहुत अच्छे से हो. This is the what is the drawback we have, because this is a prototyping. The technology is changing. One kind of satellite, if we are making say GSAT 20, so 21 will be different, 31 will be different, 32 will be different. If you are making say IRS kind of satellite, something resource set will be different, and then ocean set will be different. And that is anyway again limiting to 2-3 models and all that. And in one satellite you have 60, 65, 70 or 100 PCBs. So that is all the limit is there. So they don't have, I mean, as per the setup, as per the government framework and all that, we have our own limitation that this much of the amount and this is all there. I mean, this is very interesting that ISRO has evolved our own costing method. Nobody was given, nobody has given, there was no document that how a PCB per square centimeter will be costing, how a particular solar joint will be costing and all that. So that was very interesting to note that, and it has been, I mean, very lucky that we had all these things and we did all these things, and the credit goes to our total team, and the award also I want to dedicate to the whole team and things that what we did. These are small glimpses where our ex-chairman director also was there. For capacity building, there was a regular program and Joshi Saab and team was also involved. Many times I was also a party to it for giving the training to the industry people for hand holding, keeping their manpower and all that. क्योंकि क्या होता है कि यदि एक आदमी छोड़ के चला गया, I mean it's a very stringent rule. If somebody is not working for 180 days, that certification goes waste. I mean again it's a recertification has to be done. I mean so many things are there. उसकी eyesight पक्का होना चाहिए. यदि वो काम कर रहा है और एक कंपनी से दूसरी कंपनी में जा रहा है, देयर आल्सो ए टग ऑफ वॉर वाज आल्सो हैपेंड कि एक एक्स कंपनी, ए कंपनी है, बी कंपनी, सी कंपनी है, वो उसको 10,000 दे रहा तो 12,000 में तुम मेरे आ जाए क्योंकि मेरे नॉर्म्स के मुताबिक मेरे को शॉर्टेज है. तो दैट काइंड आल्सो हैपेंड एंड इट वाज वेरी टफ टाइम वी हैड ऑल दिस थिंग इन दोस डेज. Anyway, this is all industry interface is also getting done by our technology transfer, capacity building by our TTID division existing in the SAC ISRO. So manufacturing sector like mechanical, electronics, antenna, service industry, clients. So this is all benefits we are having with all this industry partnership with these things. So what we expect from industry that they should have expertise, infrastructure, facility design, manpower, and because we also tell them now, used to tell, now there is no question arises nowadays because already so many things have changed in the last 4 or 5 years that I am presenting in the next coming slides there. That what is the present and all. These are all PCB specifications that we used to tell them that 4 layer to 30 layers and all that micron layer. These are all the technical details we used to tell them for PCB manufacturing के लिए vendor को कैसे develop करना for PCB manufacturing also. So these are the PCBs flexible, flexi-rigid. I mean different kind of PCBs, multi-layer PCBs, copper cladded PCBs, PTFE PCBs and all these things were there. So in not only that PCB but also for design arena also for say 100 watt SSPAs and high thermal mass PCBs and for their testing, SI jobs, thermal integration and all these things are there for high speed PCBs, signal integrity, so many things. Nowadays I mean it is getting executed by the private parties, layout, routing, design, I mean all these things are basically done by the persons, by their own company, using their own satellites, softwares also, and in our own, I mean, campuses also. So what is the mantra? Mantra is basically the teamwork. The ISRO people, our team, and basically will basically lead to the success formula for these things. So now coming to the point that now what has changed in last decade? Now what was the driver? In 2016, there was only entity, ISRO was the only entity. Now, slowly the things got changed. Nowadays, ISRO and private partners are there. Everybody is aware that in space is now taking care of the private players. And what were the components used? Components were basically imported. They were heavy components in those days. Nowadays, lightweight components, and majority of the components are the COTS component. Commercial components are there, of the shelf components are there, and they are being used very, I mean, in the bulk quantity. To very surprisingly, you might notice one article, it was very interesting, 6 satellites per day. I mean, very interesting, 6 satellites per day. We used to manufacture 1 satellite in couple of years, or say 100 of the weeks, 100 weeks. And now people, I mean, Starlink has started, I mean, this Elon Musk has thought on that line, that it's a total setup, automated setup. They have made it using the COTS component. They don't bother, no middle grade component, because the costing difference is 1,000 times. If you cost is a 1 rupee component costs, costs will 1 rupee, and that your mill grade and all that maybe 1,000 tons or much more than that also. So the costing around 6 satellites per day their production. So they want to cover the whole world with the hundreds of the satellites. Now today 4,500 to 5,500 almost satellites are orbiting to us and giving us the all output, whatever we call it as the internet, or we call it as a remote sensing or the crop estimation and all that to the worldwide and all that. India normally, I mean, we are still shortfall of having in communication arena. We say still little shortfall for the transponders. We are having the certain few transponders leased by government of India. That is also there. So again, coming to that electronic focus, the COTS components. Then we have a lot of startups. People are aware, you all are aware by these things, that so many companies have come into the fray, and they are not only manufacturing the launch vehicle subsystems, launch vehicle, I mean, so many satellites they are planned to make it and all that, and chip designing also, and for that also launch also, they are already prepared, and the government has opened the doors for them. So what are the challenges we have in now today in 26? That we have the rapid growth. The challenges remain for high-end semiconductor growth, because chip availability, chip manufacturing aspects. That's why our PM Shri Modi sir is recently, yesterday only, he has inaugurated the in Anand, that is semiconductor fab facility, and for long-term capital loans and startup, it is there. So microprocessors, indigenous chips. So in our own by Chandigarh laboratory, this was developed, Vikram and Kalpana. This was developed earlier. So what is going to this year? What we are going to face? This miniaturization in avionics is going to happen. 3D printing will be the major line coming to that nowadays. That 3D printing will be there, so most of the things will be going into the 3D printing aspect, because it supports the customized and the custom and the prototyping kind of thing. Now, if we see that startup driven innovation will be there. Why it is important? Because the young minds are there. They are using most of the new latest software, AI technology, and things which are happening worldwide. They are using, and some of the companies like Dhruva Space and Pixels are pioneering, and they are doing the hyperspectral imaging and all that. So now commercialization and regulatory support. Once we have opened our skies and space for the private players, so there will be the regulatory very important. कोई किसी का सैटेलाइट को हिट ना करें, हम अपना ही सैटेलाइट अपनी स्टार्टअप जो है, so that is also very important. The policy is also should be there, and that also to be taken very careful like that way. So it's not an easy task. It's going to be very much more challenging for future also. That how to deal with these kind of things, because it is again a very, I mean, understanding the policies from the foreign, and in the Indian context we have to define for their launch pad and all that. Even I mean, I just want to tell the point. ISRO, since last in 75 years or 50 years, if we say starting from 68, 69 onwards, I mean the success rate is very good, but still we face fewer times the failure in the satellites, failure in the launch vehicles and all that. Even after having so much of treasure of knowledge, even after taking so much of precautions, still we are doing, and I mean, it's such a kind of a risky task and business. So how we have to deal with the private players? Something goes wrong, something happens, even in spite of all these precautions on that. What will be the penalty? How to deal with these things? What will be the legal aspect of that, the worldwide? So that is anyway is going to be challenge for this year. What is the growth matrix? You know, everything is very clear, transparent, that we are 1.8%, not exactly 2% in the world global economy of in the space industry nowadays today. So our vision is that we should go to that by another 6 to 7 years, up to 45 or 50 billion dollars, US dollars. Okay, we have to reach it. How to reach it? What are the hurdles? How to reach it? What are the bottlenecks? See here, the figures are very clear. We have our own space budget. It was merely 5,700 crores roughly 12 years back. It was just 5,700 crores. And Now we have, in 12 years span of time, it goes almost 2.2 times to 13,000 crores. And if I tell you, if you see the European Space Agency budget, the American Space Agency budget, it is more than 2 lakh crores of rupees. So what they decided, they followed the model. They told that let's bring to Elon Musk, let's give them the autonomy, let's support them. So India followed the same thing. In space is already has come into the line, and now the companies are there. So money has to put it. जहां आप उसमें पैसा प्राइवेट प्लेयर से मंगाओगे या इन्वेस्टमेंट करोगे तो ही आपकी ग्रोथ होगी. So that was the thought has happened. So that has happened, and now it is facing this thing. So we will be having now ministerialization, and not only that, manufacturing here in our clean room, but I mean, people are thinking worldwide that in space also, in situ, the manufacturing in space should also be there, using the 3D printer in space station and all that.
Satellites have been launched.
Satellites have been launched around more than 10,000, but today's operational situation is around 5,500, something like that. It's changing every day. I mean, actual figure, real time figure, I can give you after this thing talk, saying that. So, this is what the electronics has to survive with the vibration, thermal management, size, weight, constant, bulk and all of that. Was the older system that we used to follow a decade back. Now what is the new and current challenges? That it is a ministerialization. I mean, chota hote ja raha hai. I mean, they are manufacturing. I mean, I just told a couple of minutes back, 6 satellites a day. They make it, say 200, 300 satellites, launch it in a particular low Earth orbit, 400, 500 kilometers, put a total link and set up. If anything goes wrong, they already had a parallel thing. It doesn't make any difference because the total satellite is kind of such a miniature that even this table size is more than enough for that, one satellite. So it costs around 2 lakhs, 3 lakhs, 4 lakhs, 5 lakh rupees, a small budget, so they can afford it. So the challenge for us, India, as a India, for our space agency is now becoming 10 times more, 10 times more than. Because see, one fine day, there will be a comparison. If the cost of a satellite manufactured by the ISRO is X amount and the availability in the foreign country is Y amount, how to compromise, how to do it? That is the question for all of us. Not only for me, not only for you, it's for the whole system. They have to think very seriously on that how to deal with that kind of system is there. All this. Anyway, this is all outgassing is a very important point that what we have to deal with these things, because so many new materials are coming. So in that outgassing is these things are there. Then thermal cycling, then quartz uses. Now the quartz have been, I mean, like जिसको कहते हैं ना पूरा थोक में use हो रहा है quartz component. I mean, nobody bothers to particular serialized components and all that. Quartz use करो, quartz कोई बात नहीं. fail होगा कोई बात नहीं. Doesn't make any difference. पूरा के पूरा satellite replace हो जाएगा. What are the future challenges? I mean, what will be the future things as far as we have to do this? So in space manufacturing, I mean, for that anyway, a lot of things has to be done by our own setup and our own this thing. That in first we have to make our own Bharat space station (PSL), and then quantum materials are there because it will be a future technology, and anyway, the present it is coming up speed up. Then long duration suspectability, deep missions, advanced power management, because so many things have been changed in the couple of decades, that a lot of miniaturization has taken place. The space electronics has become the power budget and consumption and all these things, more advances. So I mean, this is again a trade-off. You have to make it in that sense earlier. So future electronics manufacturing will be what? It has to, anyway, there is a harsh environment. We are talking about Venus mission. We are talking about, in future we'll be talking about the Saturn mission. So many things. I mean, we have to search in search of the excellence, in search of the we have to go to different galaxies and all that. So all these things will be there, and all that thing is there. So where I'm linking all these things to our industry partners, because all these industry partners will not be interested here. It's very important point I just want to prove, because it's again a government baby. nobody is interested in going to Venus because Venus में satellite भेज के क्या मिलने वाला है उसको? It's a government of India budget has to be given. Then only the Venus will. Chandrayaan पे जाके क्या मिलेगा? Nobody is giving. No private party, no private player is interested in going to this spending money, spending say 4-5 crores, 10 crores, 20 crores, 100 crores of rupees in going. So it has to be funded by the government. And that has to be taken very careful, that our lab has to be made to that class, that has to deal with this kind of thing, interplanetary missions and all that. So this is very things. What are the challenges? See, if we are going up and up and on, so we have to do the components because cord components are to be used. They are not radiation hardened. So we have to make the techniques and methodologies to make them the radiation hardened. That is very again an important point. Components which is a normal because there will be so many alpha particles and atmospheric if you go things are there, so they can change the setup of your devices. So to prevent them, that you need to do some kind of red hardening. So ionization dose has to be calculated, then electronics must survive and all that. So all these things are to be very challenging, happening to be challenging.
There are so many satellites nowadays being launched. Won't there be space, traffic, space?
Yes. You are absolutely right. I will add on that space में भी कूड़ा करकट बढ़ रहा है और space में भी traffic वाली जो condition है that is there. So basically the orbit, if you see, if you just change the 0.5 degree precisely, you can again set up 200, 400, 500 satellites. So it's a beauty of orbit. So that's what I give you another example. In the launching, they have all the calculations, 74 degrees or 93.2 degree and all that. If just a 0.01 degree if it changes, or say if I say if your plane is, you are sitting in a plane, it is planned to go to Washington or say New York, and if your 0.5 degree changes, you will not go to Washington, it will land up to London or somewhere else. So that kind of thing what I want to communicate is that way is there. So that is the thing. So in the orbit, so not only geostatic, it's a 36,000 kilometer. You go up, you build a capacity, you go to 72,000 or 54,000 kilometer away from this thing. So you can get it. So there are so many orbits: LEO, MEO, geostationary, GTO.
There are miniatures right now.
Yes.
LEO.
Yes.
So in limited space. That Elon is giving so many satellites.
They got it. Because of ITU is there, they are deciding where to orbit. Your orbit is to be placed and all that. It's all based on that particular system. It's not like that. That's what I said. Indian ecosystem in Indian startup, we have to deal with various things. Suppose कल को ध्रुवा बोलता है कि मुझे satellite launch करना है. How it is to be done? Which orbit is to be given? Whether we have done it, we have made it. That particular procedure, plan and all that. कि उसको satellite उसके particular कौन सा orbit में जाएगा. So that orbit has to be booked. जैसे आप plot book करते हैं मकान बनाने के लिए, आपके parking के लिए. Same thing is like that. That your orbit has to be booked in that fashion and all that. Okay. So
we have reserved orbit with us. LEO.
Few of the things are there, but I am not much conversant about it. I have to study and then come back to you. I am not much more. Is a particular again I see. I just tell you in one line. Total space thing is basically is a combination of all branches of science and engineering. Not only in engineering but medical also. अभी आपने देखा कि उन लोगों ने माइक्रोग्रेविटी का भी वो किया. पौधे कैसे उगेंगे, मूंग के वो कैसे उगेगा, मेथी कैसे उगेगी और किस तरीके से वहां बुढ़ापा आएगा नहीं आएगा. It's not so space electronics is a very big subject. So I am a one small component in that. What I can share the knowledge I am sharing with you. So in space manufacturing, anyway, supply chain. Now it was very interesting. The supply chain has to be there. Here also the semiconductor plays a very important role in the supply management. Then high quality, high voltage insulation. Because of these things, we have to be very careful. Is there? So what is the summary table we have? What was the old thing? That reliability and survivability was very important. What is the key challenge at that time? What was the key challenge? It was high weight, radiation and the launch shock. Now what is the new thing? The new thing is that छोटे component हो गए, small हो गए, miniaturized हो गए. इसमें क्या challenges हैं? Thermal, outgassing, costs and reliability. What will be the future? Future will be all, AI based, autonomy based, advanced computing will be there. And that in space manufacturing will be there, quantum will be there, long life will be there, the total power will be there. They will be having some stations, power stations at moon also. They will be using nuclear fuel also for that, having the satellites and all that. So all these things are, I mean, it's very interesting that the Indian setup and Indian industry has to come forward. There are a lot of, many areas are there, not only that, it's a very small one, I mean, 0.01% I tell you, not only in that satellite manufacturing aspect, but into application aspect, into design aspects. I mean, so many things are, the things are open for them. Okay, so I take this opportunity to thank to our IET again headquarter award committee chairperson, IET executive committee members, and all senior members, our segment Joshi Saab and team, and all our friends and madam. And I also take this opportunity to thank our director sir, our deputy director Shri Singh sir, and all that. So now the platform is open. If we have any few couple of questions to this thing, I can take.
We have started using the cost component.
Yes.
Right, so from the bill grade, we are going to now industrial.
Yes, yes.
So what about
I pardon, I just small correction. It's not purely industrial grade component. COTS is in between the mill grade component and industrial grade. It's a commercial off the shelf component. Some kind of testing, whatever is required for the space electronic, is upgraded one.
what about the cables connectors? That is one question. And are we changing the soldering and other techniques also? Because earlier they were going for the mill grade components high level. Are we changing into that? Sorry.
Yes. Let's come to first part. Yes. So many connectors and all that, they are being used by the Elon Musk in their own setups. I mean, different connectors they are used in the COTS successfully worked. Not only that connectors, but even including FPGAs and all that, they have used it. We have the reports with us. I can share with you. That is one. Your second question is that soldering. Can you see there are different kind of things. Like crimping is they are using. I mean, like in commercial electronics, the advancement has taken place. Rigid, flexi-rigid PCBs. You are, I mean, like a computer printer and all that. We have the total. So those same kind of things. Thanks, slide. So those kind of inbuilt connectors with the PCB is already being used also for the space electronic purpose. We are using it. We have used flexible PCBs, flexi-rigid PCBs, and rigid PCBs. In our Carto satellites and other satellites, we have used all these things. So it is basically it's a, I mean, like in printer we have that kind of thing, connectors and all that. So that is already there.
One small question. Like we are going into the LEO, we are mostly in the LEO satellites. But in the LEO satellites, because there may not be so much radiation, so you can go into the cosmos. But when we go to the GEO or the space missions, still we have to go into the LEOs.
No, not necessarily. See, in our case also, many of the places, not only in the communication satellite, but into even interplanetary missions also, few of the components which were not available. The delivery was too long. Then the compromise was made. That was made externally radiation hardened. See, any component is capable of handling certain kind of rads. The unit is rad. So what we have to do, we have to use your local potting RTV3145 tube and the tantalum sheets on the component on the devices, and that will make sure even in the cover of the box cover and all that in the subsystem assembly that is calculated that from this angle the radiation may come, and that calculation is giving the assurance in the reliability calculation. This is taken care. Yeah, please. Joshi sir, you want to add something?
Because my job memory from 1978.
That's what I.
When I was in the.
So, any more questions? Yes, please. Thank you all, and it was a nice.
Thank you, sir, for your nice presentation and giving us insight of enabling India's space future, space electronics hardware realization, and industry's growth for self-reliant space mission. So please, I welcome you on the dais.
Thank you. So point is simple that काम इसमें ऐसा करना ही होता है कि जो काम ऐसा हो, ऐसा करो कि
It should give the influence. Society on for the next.
सर को
अब आप
yes, sir. Thank you. Now I would like to request Smiti Tagore Madam to felicitate our theme speaker or awardee speaker, Shri Dinesh Kumar Agrawal sir.
Thank you both.
हाँ अंकित भाई प्लीज वेट वेट हाँ सर का दे दीजिए सर कैमरा आई जस्ट थैंक यू सर थैंक यू मैडम
हम सीनियर्स को
हाँ, yes. अभी जो वेट जोन सेमिनार हुआ था हमारा उसमें हमारे पास चेयरमैन और सेक्रेटरी को हमने फेलिसिटेट किया था जो कोई मेंबर चेयरमैन सेक्रेटरी जो नहीं आ पाए उनका आज फेलिसिटेशन हमने रखा हुआ है तो पहले मैं आमंत्रित करूंगा सुधीर अग्रवाल सर को पास चेयरमैन IETE अहमदाबाद सेंटर हाँ यानी मालोटिया जी उनका स्वागत करेंगे फेलिसिटेशन हाँ हाँ सर जो थे चेयरमैन थे 2018 और 20 में हाँ
नहीं आज पुराने जितने हमारे चेयरमैन सेक्रेटरी थे उन्हीं के कारण आज IIT अहमदाबाद सेंटर इस लेवल तक पहुंचा है हमेशा ये पूरी कमेटी जो जिसने पूरा काम किया
अभी मैं आमंत्रित करूंगा आनंद मिश्रा सर को और हमारे जो चेयरपर्सन मैडम है स्मृति प्रीति अग्रवाल मैडम उनका स्वागत करेंगे सर भी हमारे बहुत पुराने मेंबर है वो भी सेक्रेटरी रह चुके हैं
Not only secretary, we have taken his advice for the INCC course.
ओह सर PRL से जुड़े हुए हैं
My secretary.
सर हमारे से PRL के सीनियर मेंबर है
Yes.
और अभी हम लोग चाहेंगे कि PRL से और मेंबर जुड़े हमारे साथ थैंक यू मैडम थैंक यू सर
हमने एक स्कीम रखी थी
हाँ यस अभी जो गोल्डन जुबली सेलिब्रेशन के हमारा जो था पूरा 2 साल का सेलिब्रेशन या 1 साल का उसमें हमने रखा था कि जो ज्यादा से ज्यादा मेंबर हमारे
पहले तो जो नए मेंबर बनेंगे
अपग्रेड होंगे
उनको हम फेलिसिटेट करेंगे
तो
सबसे पहले
अच्छा वो बाकी है
हाँ वो 2 बाकी है ना कौन बाकी है
अंकित सर है ओके ओके हाँ
अगर एग्जीक्यूटिव कमेटी में मेंबर्स को जाना पड़ा मीटिंग में तो एक जगत जी थे और
पंकज
और भी कई लोग हैं जिनका अभी फेलिसिटेशन बाकी आई
अच्छा तो ये जो है हमारा गोल्डन जुबली ईयर में ये सर हमारा मेंबरशिप अपग्रेड किया है उन्होंने तो उनका भी हमने फेलिसिटेशन रखा है हाँ यस यस और जो हमारे मैडम है उन्होंने बहुत जैसे वेस्ट जोन सेमिनार भी किया है और लोगों को मोटिवेट भी किया मेंबर बनने में तो उन्होंने 14 मेंबर को हमारे में जैसे अपग्रेड भी करा या नए मेंबर भी लाए तो हमने एक मोटिवेशन के तौर पे एक अवार्ड रखा था कि जो ज़्यादा से ज़्यादा मोटिवेट करेंगे या मेंबर लाएंगे तो उनके अवार्ड जाता है हमारी प्रीति मैडम को और मैडम ने इतना मेहनत किया सबको दौड़ा रहे
मेंबर्स को बुला देते नहीं मैं सबको कल हम
वीडियो फोटो देखने में आई है सर।
और बाकी सभी को हमने इनवाइट किया था, मैसेज डाला था, फोन भी किए थे, बट वो आ नहीं पाए। और कमेटी में 2 लोग थे, वो चले गए। अच्छा
हम जीरो राइट अप करते हैं।
हमने कमेटी में कर दिया, अर्चित जी होते हैं, तो आप सबको बुलाया।
एक फोटो और है, फोटो और है।
इसमें अगर सैंपल चाहिए तो 10 हो गए, 10 और में कल हम नेशनल साइंस से भी कर दिया। उनका ये कहना था साकरचंद में कि एक साथ 10 फैकल्टी उनकी नहीं आ सकती, वो छोड़कर वहाँ से, इसलिए फिर हम यहाँ सर्टिफिकेट,
हाँ।
इसके
हाँ
सोनल के सर्टिफिकेट,
सर्टिफिकेट में, यस ये तो मेरा ही है, ये तो
ये मैडम आपसे,
हाँ आप
नाम
आप दे दीजिए।
बोलते जाइए।
पहले
मैं तो
नहीं
आपको, रसेश भाई बहुत मेहनत की, बहुत काम किया, लास्ट मोमेंट पे हमारे सेक्रेटरी बने, बट बहुत संभाला उन्होंने।
थैंक यू मैडम।
Research by true hard work.
थैंक यू। मैंने पूरी आईपीआर की टीम को लगा दिया, मैडम ने मोटिवेट किया और पैसा लाया मैडम। मैं तो पहले ही बोलूंगा फाइनेंशियली मैडम का सपोर्ट अच्छा रहा, बाकी दौड़ने में तो हम लोग थे, लेकिन जो इवेंट लाना और स्पॉन्सरशिप, ये 2 बड़े काम उन्होंने कर दिए।
ट्रेजरर के भी चाहिए।
हाँ सर ने हमको खर्चा करने दिया।